Next part, that is intensive and extensive properties. Both intensive as well as extensive, they are thermodynamic properties. Now intensive properties क्या होती हैं, which do not depend on either the size of the system or quantity of the matter present in it. Means intensive properties are one. What are intensive properties? The properties of a system which do not depend on either the size of the system as well as quantity of the matter present in it. Okay, so that is called intensive property. For example, like we have temperature. Let us take this box, or we can say take the building. Okay, in this building, let us take temperature of this whole room is T and pressure of this room is P. Okay, now what I do, I make a partition. Okay, this is the hall. Okay, that hall is divided into two parts. Now tell me, what is the temperature and pressure now? Is it remain same or changes? Okay, take volume as well. We divide it into two equal halves. So tell me now, what happens to temperature, pressure or volume? These three properties. What I do, I have a big room or hall, we can say, and I divide it into two parts. Okay, to room 1, room 2. Temperature remains same. Temperature remains same. Pressure remains same. But volume is halved. Volume is halved. That implies that temperature and pressure, they are intensive properties because they do not depend upon the size of the system. Or we can say, no beta, there is no change in pressure, because let me tell you one thing, that when it is divided into two halves, what happened? Number of gaseous mole also changes, also divided into two equal halves. See, if we apply just this relation, PV equal to nRT, okay. So pressure is equal to nRT over V, right? You have identified temperature is same, R is same, N is halved and volume is halved. So obviously pressure remains same because N is halved, volume is also halved. Yes, if number of moles are N, then it becomes N by 2, N by 2. Pressure is force over area, okay, right? So when it is divided into two equal halves, force also changes, force also decreased, area also decreased. Both are decreasing simultaneously. Force does not remain same because force is the impact or collision of the molecules. So molecules decreases, so obviously force will decrease. Force and area both will decrease. Okay, great. Now, intensive properties, they do not depend upon the nature of the substances. That is the most important part. They do not depend upon the nature of the substances present in the system. Okay. So, another examples, pressure and temperatures are example. Any other example? Pressure, temperature. Now tell me, if I have a piece of iron, let us take a piece of iron. Now I divide it into equal halves or any other halves. Okay, I divide this into parts. Okay, so tell me what happened to their density and mass. Let us take its mass as m and density of the piece is d. Okay, and volume as v. Okay, so obviously mass is going to decrease, mass will change, volume will change. Now tell me what happened to density. There is a change in density or density remains same? Mass will decrease, volume will decrease. Okay, but density remains same. Got it? Because density is mass over volume. Because they are divided into equal 6 halves, then it is m by 6 mass of each. Volume is v by 6, so it remains m by v. M by 6 over v by 6, so it remains m by v. So density remains same. Now tell me, melting point, is it intensive property or extensive property? Boiling point, yes. Viscosity, surface tension, they all are beta intensive only. Because if we have iron, its melting point is fixed. If we have water, water is 1 liter or 10 liter, its boiling point remains same. Is there any change in boiling point? Boiling point will remain same. Water at 1 atmosphere pressure, its boiling point remains 100 degrees Celsius. Volume may be 1 liter or 10 liter or 100 liter, whatever it is. Only heat is different. Okay, amount of heat absorbed is different. But boiling point and melting point remain same. Surface tension is force per unit length. It also remains same. Viscosity remains same. So, these are all intensive properties. Okay? Melting point, boiling point, viscosity, density, surface tension, pressure, temperature, all are intensive properties. After getting all this, Now extensive properties. Extensive properties, they depend upon the properties which depend upon the quantity of the substance, okay, or quantity of the matter present in the system. Okay, and its magnitude changes with the change in the amount of the substance. That means their magnitude changes, their value, or we can say, you can say their value changes with change in quantity. Okay, of the matter. For example, if we talk in terms of mass, mass will change with the change in amount, right? Volume, that will also change. Heat will change, okay? Work, they are all extensive properties. But when two extensive properties are divided in, they become intensive. Okay, if we divide two extensive properties, we get intensive properties. Yes, surface area is extensive. Okay, for example, say mass and volume. So density is mass by volume. Okay, anything per mole, like anything divided by means Q divided by N. Okay, so Q is extensive, N is also extensive, means quantity, moles. Okay, extensive, but when heat is divided by N, then it becomes intensive. Okay, anything divided per mole, ठीक है, any enthalpy per mole, that is intensive property. Okay, so keep in mind, ratio of the two extensive properties is always an intensive property. Got it? If we divide two extensive properties, or you can say a ratio of two extensive properties is always an intensive property. Okay, density is one of the example. Next is thermodynamic state of the system and state functions. Okay, so a system undergoes change as a result of chemical reaction, that all. any system can undergo a change as a result of chemical reactions. So it can be described before and after the change in terms of certain properties. Like, main properties are, which are we can say fundamental properties: pressure, volume, temperature, and composition. So when a chemical reaction takes place, there may be a change in pressure, there may be a change in volume, there may be a change in temperature or composition, and these are known as state functions. So these are known as state functions. So to define any state, what we do? We define its pressure, its volume, its temperature and composition. Out of these four, we have to define three, and fourth is automatically fixed. So these are also called state variables. These are also called state variables or thermodynamic parameters. Or state of the system is known as thermodynamic state, right? So pressure, volume, temperature and composition, out of these four we have to define at least three. Okay, because if we change pressure or volume or temperature or composition, if we change any one of them, state of the system will vary. Okay, that's why they are known as state variables, state function or thermodynamic parameters, right? So state variables, except these pressure, temperature, volume, there are other state variables as well, as like enthalpy, that we will going to discuss in the lecture. Enthalpy, it is denoted by H. Pressure is denoted by capital P, volume is denoted by capital V, temperature is denoted by capital T. Okay, enthalpy is denoted by capital H, entropy that we discuss in our coming lectures, entropy, then free energy. These are all terms related to thermodynamic variables. Okay, number of moles, composition means number of moles denoted by N, and PV equal to nRT, that is the equation of the ideal gas equation. So pressure, volume, temperature, number of moles, they are in that particular equation, right? So from this PV equal to nRT, we can identify P, V, N and T. If these four variable changes, every state of the system will change. That means to define the state of the system, what we do? So state function and state variables or thermodynamic parameters you came to know. Okay, now to define the state of the system, state of the system also known as thermodynamic state. is defined when we specify any three variables out of temperature, pressure, volume and number of moles. Okay, so that is called state of the system. Okay, a state of the system, that is also called thermodynamic state, is defined when we specify any three variables out of temperature, pressure, volume and number of moles. That is called state of the system. Okay. Now, if we have state 1 that can be changed into state 2, this is initial state and this is okay. State means if for the system we define its pressure, volume, means it is known to us what is the pressure of the system, what is volume of the system, what is temperature of the system and how many number of moles are there in the system, then that is called state of the system. No. State, solid, liquid, gas. In thermodynamics, state of the system means what is the pressure of the system, what is the volume of the system, what is temperature of the system and how many number of moles are present in the system. Okay, got it? Got it? There are two types of functions, state function and work function. Okay, so state function means state function can also be defined as the variables like the variables like temperature, pressure, volume, number of moles, enthalpy, entropy, free energy, are physical quantities and their values depend upon the initial and final state of the system and does not depend and do not depend upon the path by which the change has been brought. Okay, so that is called state functions. Okay, got it? Means, let us take example potential energy. You know, potential energy is also a state function. Potential energy is also a state function. Now say if we are on the, let us take ground floor. Okay, we are on the ground floor. Okay, from the ground floor we go up to the 7th floor. Okay, 2%. Okay, or we can say same person first go by stairs. Okay, and second time he went by lift. Okay, escalator. Now tell me, क्या बोलते हैं उसको, escalator ही बोलते हैं, I don't know, I will write lift. Okay, so tell me, if height is h, mass of the person is m, acceleration due to gravity is g, so potential energy remains same. In potential energy, if you calculate, then you have to know mass, you have to know acceleration due to gravity, you have to know height. How this height is achieved, that is not counted, that is immaterial. Got it? Yes, anyone who has doubt in it? State function because it depends upon the initial and final floor, means initial system and a final state, initial state and a final state. It does not depend upon the path followed. So that is called a state function. State function means the variables which depend upon the, means their value depends on the initial and final state of the system, and it does not depend upon the path followed. That is in the smallest, these are the, means shortest words, or we can say shortest statement, that depends upon the state of the system independent of the path followed. You know, when a person go by stairs, you know, he will do more work, and the person will, that will go by lift, that will lead to less work. So work is a path function. Path function means which depends on the path. The variable, its value depends on the path followed. Good evening, Harshil. Okay. Now, as we say, the thermodynamic changes, you know, so there are different processes. So let's discuss about thermodynamic processes. say there are small things in thermodynamics which are very important. See, first we see what is system, what is surrounding, then we have that open system, closed system, isolated system, homogeneous system, heterogeneous system. Today we have next part, that is intensive property, extensive property and state functions. Okay. Now thermodynamic processes. So, when a thermodynamic system changes from one state to the other, the operation or process is called thermodynamic process. Means system 1 to system 2. So, when it changes from system 1 to system 2, okay, this is first thermodynamic system. This is not transition state, thermodynamic system 1 and thermodynamic system 2. So, when this system, thermodynamic system 1 changes it to thermodynamic system 2, the process or the operation, that is called thermodynamic process. Whatever operation we do, operation or process, because to change system from one state to the other, what we do? We do some operations. So, there are various types of processes. First one is isothermal process. Isothermal process. Now tell me, what is isothermal process? Isothermal. Yes. Anybody? Iso means same, and therm means temperature. Yes. What it means? So, any process is said to be thermal, isothermal, sorry, in case temperature of the system remains same, right? That is, temperature of the system is constant, or we can say operation is carried out at constant. Yes, very good. Temperature is constant. Any process in which temperature is constant. Okay. Or how is it possible? Tell me. Yes, temperature, we have to keep the temperature constant. While process is going on, temperature should be same. That means it is possible only when the system is in thermal contact with the surrounding. That means walls are diathermic. and heat energy can be exchanged. Between the two, means between the system and because say beta, see if there is no change in, let us take example of isolated system. Okay, let us take, this is the isolated system. Okay, walls are insulated. Okay, walls are insulated. At the same time, this covering, that is piston, is also insulated. Okay, and reaction taking place inside, and that reaction is endothermic. That means heat is absorbed. So when this reaction takes place, tell me, what is the temperature of the reaction mixture? Reaction is going on in the container and reaction is endothermic. Now tell me, temperature of the mixture decreases or increases? Yes. I took isolated system. Okay, and in the isolated system, reaction is going on inside the beaker. Okay, there is no exchange of heat, as you said. That is the myth. Temperature will decrease because temperature will decrease. Why is it so? Mansi, Abhay, I think you thought of that endothermic reaction. So heat is absorbed. So it cannot be absorbed from surrounding. It cannot be absorbed from the surrounding. It can be absorbed inside only, because there is no surrounding for isolated system. So heat content of the mixture will decrease because it is absorbing the heat from the reaction mixture itself. So temperature will decrease. Try to understand this thing. Let us think that heat content of the system is 10 joule. Out of 10 joule, 2 joule will be absorbed because reaction taking place with the absorption of heat. Okay, so when this heat is absorbed, it cannot be absorbed from the surrounding. So now its heat content becomes 8 joule only. So temperature will decrease. That means isolated, it cannot be isolated system. Okay, it cannot be an isolated system. It should be in thermal contact with the surrounding, so that if it need heat, it can be absorbed from the surrounding, so that temperature remains same. That's why I write here that system is in thermal contact with the surrounding and heat energy can be exchanged between the two. Only then temperature remains same. And it can flow from system to surrounding or surrounding to system. So tell me, to make it isothermal in endothermic process, what is the flow of heat? Endothermic process and how is the flow in exothermic process? Direction of flow. That is absorbed from the mixture itself. That's why heat content of the mixture decreases. Now tell me, if endothermic process is there and walls are diathermic, that means walls are conducting. Yes, in endothermic process, flow of heat is from surrounding to system to keep the temperature constant. In exothermic, it flows from system to surrounding to keep the temperature constant. Okay. So, it means in isothermal process, by any means we have to keep the temperature constant. Okay. Or it means change in temperature should be 0. dt is change in temperature. Okay. So next, this is isothermal process, okay, in which temperature should be kept constant. Now second is adiabatic process. So in adiabatic process, no exchange of heat, no heat exchange of heat between system and surrounding. No exchange of heat between the system and surroundings is possible. So that means now system is completely isolated or insulated from the surrounding. Okay. Now there is isolated system. So tell me, in this case, if change is carried out in the system and that if it is exothermic, then what happened? Temperature of the system increases or decreases? Or if it is endothermic, then what would happen? Yes. Yes, process is adiabatic. That means if we take thermos flask or any insulated container and exothermic reaction takes place or endothermic reaction takes place. So what would happen? Very good. In exothermic process, temperature increases. Okay, there is increase in temperature, right? Because heat cannot go outside, so it remains in the mixture, and Endothermic, heat cannot be obtained from the outside, so it is absorbed from the system itself. Yes, in exothermic temperature will increase and in endothermic temperature will decrease. That means in case of adiabatic process, temperature does not remain constant. The temperature of the system does not remain constant. But in this case, Q is 0. dt is not equal to 0, but Q means heat. Heat cannot be absorbed or heat cannot be released to the surrounding or absorbed from the surrounding. Means system cannot absorb heat or evolve heat. Okay, because there is no connection between the system and surrounding. So in adiabatic process, Q is 0 and dt cannot be 0. There is always a change in temperature. Okay. Isothermal, I think you should know it, because isotherm we have done in states of matter. Isobars. Now tell me, isobaric process. What is isobaric process? Fast. Isobaric. A process is said to be isobaric if in which pressure remains constant. Okay, pressure remains constant throughout the process. That is, P is constant, or we can say dP equal to 0. Yes, same pressure. Okay, the volume may or may not change, right? But pressure remains constant. Okay. Then come to isochoric process. So what do you mean by isochoric process? Yes. जल्दी जल्दी. Isochoric. Hi beta Ganpati. Okay, Siddharth, but only few minutes, only 2 or 3 minutes. Okay. So in isochoric, volume is constant. That means V is constant and dV is 0. Pressure may or may not change. So that is called, yes, very good, cyclic process. Yes. In cyclic process, what happened? When system undergoes a series of changes and finally returns to its initial state. For example, if system is at stage 1, it goes to 3, it goes to 4, it goes 3, 4, 5, 6, and then return back to original. Means when a system undergoes a series of changes and finally returns to its initial state. So that is called cyclic system, and there is no change in energy in a cyclic process. No change in energy. Okay, that means E is constant, or we can say dE is 0. Okay, right? So this is all about the processes reversible and irreversible. We will discuss in the next lecture.